So our last example for the day. Alright, so we've got an x equation, a y equation. This one we're just looking at some tricks. We've got sine and cosine. First thing it asks for is dy dx and the second derivative. Alright, so let's start by finding x prime and y prime. So x prime is equal to derivative of square root of 3 is just 0. Derivative cosine is a negative sign, so it's going to give me a positive 4 sine of t. Then y prime is equal to derivative of 1 is 0. Derivative sine is cosine, so I've got a negative 2 cosine of t. Right, so we know dy dx is just dy dt divided by dx dt, or y prime divided by x prime. So what we have here is negative 2 cosine of t divided by 4 sine of t. And since they're asking for the second derivative, let's go ahead and simplify that using trig identities. So we got dy dx is equal to negative 1/2, and cosine divided by sine is just cotangent of t. Alright, so there's our first derivative. Now to find the second derivative, we know we need to take the derivative of the first derivative and then divide by dx dt. So don't lose that second part. So I got d2y divided by dx2 is equal to. So the derivative of a negative 1/2 cotangent of t, so derivative of cotangent is a negative cosecant squared, so I end up with a positive 1/2 cosecant squared t divided by dx dt, which is 4 sine of t. Now we can go ahead and clean that up a little bit too, so I've got a second derivative that is equal to, so 1/2 divided by 4 is going to give me 1/8. And I've got a cosecant squared divided by sine, and remember 1 over sine is just cosecant, so what we really have is cosecant cubed t. And this is a 1 over 8. Alright, so that is our first and second derivative. Part B is asking for the path of the particle intersects the x-axis. Alright, so what we're looking for are x-intercepts. We know that x-intercepts occur when y is equal to 0. I'm going to come up here and I'm going to set y equal to 0 to find my a and b values. So we've got 0 is equal to 1 minus 2 sine of t. So what we have is 2 sine t is equal to 1. Sine of t is equal to 1/2. So where is the sine equal to 1/2? So that's going to be when t is equal to pi over 6 and when t is equal to 5 pi over 6. So that's just going to be our a value, a and b values. And now we just need to know the distance. So we just have a formula here. So I know my distance is going to equal, I'm going to integrate from pi over 6 to 5 pi over 6. It's asking us to write the expression but not actually evaluate. So I've got the square root of dx dt. We already know dx dt was 4 sine of t, and we're going to square it, plus dy dt. We also know dy dt is negative 2 cosine of t. We're going to square it, and because we're integrating, don't forget the dt at the end.